Suppose that you have a class that can use graphics to draw various types of data such as strings, integers, doubles, etc., and that contains a method for drawing each data type. It is cumbersome to use a new name for each method. For example, draw string, draw integer, draw float, draw double, and so on. When you got ready to use those methods, you would need to make sure that you use the appropriate method with the appropriate data type. If we make a mistake, we're going to end up with an error. Since all the methods do the same thing, we can simplify our code. In the Java programming language, you can use the same name for all the drawing methods, but pass in a different argument list to each method. Thus, the drawing class might declare 4 methods named draw, each which has a different parameter list. This is called method overloading. Depending on the type of parameter that we pass in to the method, it will determine which method to run. Method overloading is a feature that allows a class to have 2 or more methods with the same name if their argument lists are different. In the Java programming language, you can use the same name for all the methods that do the same thing, but pass in a different argument list to each method. Thus, you have one method that performs the same basic task, but differs based on the different parameters it receives. Argument lists could differ in the number of parameters, data type of parameters, and finally the sequence of the data types of parameters. Let's look at some examples. Example 1 demonstrates overloading by using a different number of parameters in the argument list or accepted parameters for the method. In this example, runaroundThe method has been overloaded based on the number of arguments. We have 3 total definitions for runaroundThe method. The first method takes 1 argument, second method takes 2, both strings, and the third one takes 3, both strings. Which method runs depends on the number of parameters it receives. When the method receives 1 parameter, it's going to run this first instance of runaroundThe. Whenever it receives 2, it'll run the second one and change the wording appropriately. And then if it receives 3 strings, it'll run this last method. Example 2 demonstrates overloading by using different data types of arguments. In this example, the method addThemUp is overloaded based on the data types of the arguments. In the first method, it takes 2 ints as the parameter. The second one has the same method name, but it takes doubles as the parameter. And finally, the last method takes strings. Again, which method is run is determined by the data types we pass in. This first example will run the method that passes in the ints because there are 2 int parameters passed in. Second one will run the 2 doubles, and the last one will of course run the strings. What happens if we have ambiguity in the data types? Java is going to assume you meant to use the one with more precision. This method takes a double and an int, but it is going to assume that we meant to run the one with the 2 doubles because that is more precise. If we take a look at the one that runs an int and a double, because of the precision of the 3.7, it's going to treat that as a double. So then it will assume that this is meant to be a double as well, and it'll run the one with more precision, even though it was intended to be ran as an int. If in doubt, run test data to make sure that the method run is the one that you're intending to be run in that instance. Example 3 demonstrates overloading by adjusting the sequence of the data types of the arguments. The display method is overloaded based on the sequence. Both the methods have a different sequence of the data type in the argument list, even though they have the same types of arguments. The first method has an argument list of int string, and the second has string int. Since the sequence is different, the method can be overloaded without any issues. The final example demonstrates overloading by adjusting the sequence of the data types, just like in example 3. But it also illustrates the use of different number of parameters. You can adjust your overloaded methods for the type of parameters you'll need. Let's look at a few invalid cases of method overloading. This example has methods where the argument lists are exactly the same. Both methods have the same number, data types, and sequence of the data types in the argument list. This gives us a compile time error. In the final example, this is not method overloading because the method names are not the same. Both of these do the same type of task. The only detail that varies should be the data type of the parameters. In order for it to be method overloading, both the methods must have the same name. In conclusion, method overloading is a powerful feature in Java because it allows you to create the same method but differentiate it based on the parameter list. This means that you don't have to create a special function for each list of parameters, but you can use the same name of the method with a different list of parameters.